The National Electrical Code, or NEC, does not impose a specific limit on the number of subpanels that can be connected to a main service panel. However, a critical factor to consider is that the combined load of all subpanels must not exceed the overall capacity of the main service panel. The NEC stipulates that the cumulative rating of the main circuit breakers within a subpanel should not surpass the ampacity of the feeder conductors supplying that subpanel. Furthermore, the main circuit breaker in each subpanel must be rated no less than 80% of the feeder's ampacity. To illustrate, consider a 200 amp service where the intention is to install two 100 amp subpanels. Such an installation is permissible, provided firstly, that the main circuit breaker in each subpanel is rated at 80% of the feeder's capacity, which in this case would be 80 amps derived from 100 amps multiplied by 0.8, and secondly, that the total load on both subpanels, which is 200 amps, does not exceed the 200 amps capacity of the main service panel. Additional factors to consider are firstly, the feeder supplying the subpanels must be adequately sized to manage the total load of all circuits within the subpanels. Secondly, the subpanels must be installed in compliance with all applicable NEC requirements, including proper grounding and bonding procedures. And thirdly, it is advisable to label all subpanels and their corresponding feeders to facilitate straightforward identification and maintenance. Furthermore, if the total load on the subpanels exceeds 80% of the main service panel's capacity, it may become necessary to upgrade the main service to avert overloading and potential safety risks. In practical applications, it's crucial to perform a load calculation to accurately determine the anticipated load on each subpanel. This calculation will help ensure that the feeder size is appropriate and that the subpanels are not overloaded. The feeder conductors supplying a subpanel must be sized according to NEC Table 310.16 or other relevant tables for the specific type of conductor being used. The ampacity of the conductors must be sufficient to carry the non-continuous load plus 125% of the continuous load. Continuous load is defined as a load that operates for 3 hours or more. Overcurrent protection for the feeder conductors must be provided by a circuit breaker or fuses rated to protect the conductors in accordance with their ampacity. The subpanel itself must be listed and labeled by a recognized testing laboratory, such as Underwriters Laboratories or all. The listing ensures that the subpanel meets safety standards and is suitable for its intended use. Grounding and bonding are critical for safety in electrical systems. The subpanel must be properly grounded to the grounding electrode system of the building. This is typically achieved by connecting a grounding electrode conductor from the subpanel to the grounding electrode, such as a ground rod or water pipe. Bonding ensures that all metallic parts of the electrical system are electrically connected, providing a low impedance path for fault currents to flow back to the source. This helps to trap the overcurrent protection device and clear the fault quickly, reducing the risk of electric shock. The neutral conductor in the feeder supplying the subpanel must be isolated from the subpanel enclosure. This means that the neutral conductors should not be bonded to the subpanel enclosure. The equipment grounding conductor, however, must be bonded to the subpanel enclosure. This ensures that any fault current will flow back to the source through the equipment grounding conductor, tripping the overcurrent protection device. When installing subpanels in different buildings or structures, additional considerations apply. The NEC requires a disconnecting means at each building or structure to disconnect all ungrounded conductors. This disconnecting means must be readily accessible and located either inside or outside the building or structure. The grounding electrode system must also be established at each building or structure. This typically involves installing a ground rod or the grounding electrode and connecting it to the equipment grounding conductor. Surge protection may be required or recommended in certain situations, such as in areas with frequent lightning strikes or where sensitive electronic equipment is used. Surge protective devices, or SPDs, can help protect electrical equipment from damage caused by voltage surges. SPD should be installed at the main service panel and its subpanels that serve sensitive equipment. The NEC provides specific requirements for the installation of SPD in Article 280. Proper labeling of subpanels and circuits is essential for safety and maintenance. Each subpanel should be clearly labeled to indicate its function and the areas or equipment it serves. Circuit breakers and fuses in the subpanel should also be labeled to identify the circuits they protect. This helps to prevent confusion and ensures that the correct circuit is de-energized when performing maintenance or repairs. When working with electrical systems, it is crucial to follow all safety precautions and use appropriate personal protective equipment, or PPE. This includes wearing safety glasses, gloves, and insulated tools. Always de-energize circuits before working on them and verify that they are de-energized using a voltage tester. If you are not comfortable working with electrical systems, it is best to hire a qualified electrician to perform the work. The NEC is updated every 3 years, so it is important to stay current with the latest requirements. State and local jurisdictions may also have their own electrical codes and regulations that must be followed. Always consult with a qualified electrician or electrical inspector to ensure that your electrical installations comply with all applicable codes and regulations. In summary, the NEC provides comprehensive guidelines for the installation of subpanels. While there is no specific limit on the number of subpanels, the total load on all subpanels must not exceed the capacity of the main service panel. The feeder conductors supplying subpanels must be properly sized and protected, and the subpanels must be properly grounded and bonded. By following these guidelines and consulting with qualified professionals, you can ensure that your subpanel installations are safe and compliant with the NEC.